Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0235, indicates that the turbocharger boost sensor is experiencing an issue, specifically signaling that it is out of range. This sensor is pivotal for ensuring that the engine's turbocharger system is functioning properly, as it relays essential data about the boost pressure back to the vehicle's powertrain control module, PCM. The PCM utilizes this data to adjust fuel delivery and optimize engine performance. In the Honda CRV 2017 to 2022, this sensor is located on the intake manifold near the turbocharger. Identifying issues with this sensor is crucial, since a malfunction can lead to performance deficits, increased emissions, and potential engine damage. Therefore, understanding how to diagnose and repair this DTC is essential for maintaining vehicle performance and reliability. The turbocharger boost sensor plays a vital role in the engine's overall performance by monitoring the pressure of the air entering the engine after being compressed by the turbocharger. This data is essential, as it allows the PCM to make real-time adjustments to maintain optimal performance efficiencies and emissions levels. In the Honda CRV, the sensor is typically located on the intake manifold, closely positioned to the turbocharger. When operating correctly, it should send a voltage signal that accurately reflects the boost pressure levels. If the voltage signal deviates from expected thresholds, it triggers the DTC P0235, indicating that the sensor is unable to accurately report boost pressure levels, potentially leading to poor engine performance. When troubleshooting the DTC P0235, several possible causes need to be examined. Firstly, the turbocharger boost sensor itself may be damaged or malfunctioning, leading to incorrect voltage readings. Secondly, wiring issues, such as short circuits or open wires in the connections between the sensor and the PCM, can lead to loss of signal integrity. A faulty PCM is another potential cause, although less common. It's also crucial to check connections for corrosion, damage, or poor contact. This multifaceted approach ensures that all potential issues are addressed, allowing for a comprehensive evaluation of the systems surrounding the turbocharger boost sensor. The manifestation of DTC P0235 can present itself through several noticeable symptoms. Drivers may experience poor engine performance as the turbocharger struggles to function correctly. This can result in sluggish acceleration and reduced engine responsiveness. Additionally, the check engine light will likely illuminate, prompting the need for diagnostic evaluation. Another symptom can be a noticeable reduction in boost pressure, leading to a decrease in overall engine efficiency. Left untreated, these symptoms can adversely affect fuel economy and increase vehicle emissions. Recognizing these early signs can facilitate timely repairs and prevent further engine damage. In the first troubleshooting step for DTC P0235, you need to ensure the vehicle is in the on mode, which is essential for activating the electronic systems necessary for diagnosis. Next, use the Honda Diagnostic System, HDS, to check various parameters related to the turbocharger boost pressure sensor. Specifically, you are looking at the voltage reading from the turbocharger boost pressure sensor compared to the expected threshold, which is less than 0.37 volts. If the conditions match the threshold, this indicates that the problem may not be present at this time. If they do not match, it signals a possible intermittent failure, suggesting that further examination into potential poor connections or loose terminals is warranted. In this step, you will first turn the vehicle to the off or lock mode to ensure safety and compliance with electrical testing protocols. After ensuring the vehicle is powered down, disconnect the turbocharger boost sensor by removing the 3P connector. It is critical to have the vehicle in off mode during this action to prevent any unintended electrical arcs or shorts. After disconnecting the sensor, turn the vehicle back to the on mode. Again, check the parameters with the HDS to evaluate the current voltage readings from the sensor. If the voltage is below the specified threshold of 0.37 volts, you should proceed to the next step, indicating a deeper issue that needs investigation. At this stage, you will measure the voltage between the designated test points when the turbocharger boost sensor is disconnected. This involves checking between test point 1 and test point 2, which correspond to specific female terminals in the 3-pin connector. You should perform this task with the vehicle still in on mode. Ideally, the reading should be approximately 5.0 volts. If the voltage reading does show approximately 5.0 volts, this indicates that the sensor itself is likely defective and requires replacement. In contrast, if the reading is inadequate, further investigation is necessary before assuming the sensor is at fault. The focus of this troubleshooting step is to verify the integrity of the VCC2 wire, which supplies power to the turbocharger boost sensor. Begin by turning the vehicle to the off or lock mode for safety precautions. You will first jump the SCS line using the HDS, waiting for at least a minute, which helps clear codes and reset the system. Once that is complete, disconnect the PCM connector E, ADP. After this, you'll check for continuity between the designated test points that include the disconnected turbocharger boost sensor connector and a specific pin in the PCM connector. If continuity exists, the VCC2 wire is in good condition, and it becomes necessary to explore authorized service information related to DTC symptoms. If discontinuity is confirmed, you will need to repair the open wiring in the VCC2 line. In the final troubleshooting step, you will examine the possibility of a shorted wire in the P3 line. Repeat the initial steps to ensure the vehicle is off and the SCS line is jumped again, waiting for more than a minute. Subsequently, disconnect the PCM connector E, ADP, as previously done. Your main task will be to check for continuity between the identified test points, this time focusing on the turbocharger boost sensor connector and body ground. If continuity is present, it indicates a short in the P3 wire and necessitates repair. If no continuity is present, then the P3 wire is functioning correctly. At this point, you may need to consult further service information or consider substituting the PCM for a known good unit. After completing all necessary repairs and replacements, the final step involves verifying the success of your repair efforts. Begin by meticulously rechecking all the connections associated with the turbocharger boost sensor to ensure they are secure and free of corrosion or damage. Once you have confirmed the proper connections, proceed to clear the DTC P0235 from the vehicle's memory using the Honda Diagnostic System, HDS. Following this, it is crucial to retest the system by taking the vehicle for a drive to observe if the DTC reappears. If the check engine light remains off and the engine operates smoothly, the repair can be deemed successful. To prevent future occurrences of DTC P0235, implementing a routine maintenance schedule is essential. Regularly inspecting the connections to the turbocharger boost sensor can help preemptively identify any issues such as corrosion or loose terminals. Additionally, performing periodic checks on the sensor's functionality can ensure it operates within specified parameters, providing accurate readings to the PCM. Engaging in preventive maintenance not only prolongs the life of the sensor and associated wiring, but also enhances overall engine performance and efficiency. These practices are crucial for maintaining vehicle reliability and ensuring optimal operation over time. In conclusion, understanding DTC P0235 and the underlying issues associated with the turbocharger boost sensor is vital for maintaining optimal vehicle performance. Systematic troubleshooting, as outlined, provides a clear path to identifying and resolving faults, ensuring that all aspects of the sensor and associated wiring are thoroughly examined. By recognizing the symptoms and adhering to the suggested maintenance strategies, vehicle owners can mitigate future risks and enhance the reliability of their Honda CRV. Overall, regular checks and thoughtful repairs are integral in preserving the efficiency and longevity of the turbocharged engine. Please like and subscribe to the channel. See you next time.